for a minute. We are scheduled in this class to take the final on Monday the 22nd, week from today, at 2 p.m. in this room. I will be here at 1:45. The reason I'll be here at 1:45 is because that's the time that the class right before us is scheduled to be out. And if they're having a final, they should be letting out about that time, and if they're letting out, we'll move right in. That means anyone who has scheduled a 3:45 class, or 3:45 final, meaning that you've got a class that is a Tuesday-Thursday class that starts somewhere between 9:45 and 10:15. That's when that final should be. You'll have exactly 2 hours before that one starts. So I'll be here 15 minutes before the official starting time of 2 o'clock. Okay? No one will be turned away, kicked out at the end. If there is another class coming into this room, it's 3:45, and there could be, anyone who is not finished at that point will pick up and we'll go find another spot to finish. So there will not be a timed part of the test. The test is going to be similar to what we've seen in the past, hybrid. It will be partly bubble sheet and partly write-on. It will be comprehensive. It will not be timed. However, if you come and take the test and say, well, I can't finish because I've got to go finish another test, the only way I would allow you to do that is for you to tell me beforehand, and I give you a page at a time. Understand what I'm saying? So in other words, you can't have a chance to look over all my tests, go take another test, and then study for the part you didn't really understand. So once you start taking it, it's not timed, but if you're going to take off for another test, then you either need to tell me up front so that I can hand you out. So every time I hand you a page, that page must be finished before you leave. Does that make sense? It will be open calculator, any calculator you choose, so whatever you're comfortable with, whatever you've been using. What else? Questions? Devin, did you have one that I didn't answer? Or?
Why aren't the tests scheduled to be taken at the time of class?
The tests are scheduled to be taken during the final exam schedule.
Why do they do it that way? Because when I set out my schedule at the beginning, because I have 2 jobs and 2 kids, and I can work it out, but the way that I line up my schedule is because I have time open. So when the schedule takes at 2 o'clock, when I don't have... When your
class that you were taking wasn't at 2 o'clock,
yes.
It interferes with your employment.
Why do they do that?
The reason they have a final exam schedule is so that every teacher in every class could give an exam during this time, and it should never conflict with each other. You know what I'm saying?
The final exam schedule is posted within the first week of this semester.
Yeah.
Why don't they just...
Because otherwise, as he said, you'd only have like an hour.
We'd have an hour instead of it's officially an hour and a half, but with 15 minutes on each side, you actually have 2 hours, and you'd really be pushed, many of you, to get it done during a class period. And so they make them longer, they make them 90 minutes, and to do that, they make a schedule. And I guess the thing that I would recommend is during week 1, when that final schedule comes out, talk to your employer and say, on this day I've got this, can we work around it? Okay?
One more question.
Yeah.
When will our personal resources
I know one thing absolutely certain. They give me a deadline, and I haven't heard of it. When I get, all grades must be posted by this time. When the finals were Thursday, Friday, it was the following Wednesday at noon.
It's still the same.
But I don't know what it is now.
According to my 304 class, it's
I mean,
following
do you guys, have you seen anything
It's
of
at
when
Wednesday.
grades will be made available to students? It's the day before that at noon is my deadline, and I can guarantee they'll be done by then. Huh? Everything has to be done because grades have to be put on by then. Does that make sense? So, hopefully earlier than that, but that is for certain. That's my best answer at this point. Yeah, question.
I have a question, but on
I haven't got it put together totally. But I would say 95% or more of you should finish in that allotted time.
an hour and a half.
Yeah. Some of you are just so meticulous and so, you just, I've worked with students enough, but most of you should finish it easily in that. I have not given this exact one, but some students will finish up in under an hour, perhaps. Some. Those that, yes.
Is the personal resource due Friday, or is that when, if we need feedback? If we want feedback?
I think I've got it down for this class to be due at 2 o'clock on Monday before you come, is when the resource is due. I think I've got, is it Friday at midnight? Is if you want feedback on the reflection part, submit your best work then and up by then, and then you'll have the weekend kind of, and Monday morning to put that, make any changes on those reflections you need to.
I have one more question. I have an exam 12 to like 1:50.
On Monday,
Yes.
it's 12:15 to 1:45 is when it's scheduled.
Yes. So, I don't know, sometimes if I'm late at all, is it gonna be?
No, that's not a problem with me.
Okay.
As long as you can stay after, I mean, if you get held up at that one for 20 minutes, half an hour, whatever, just come in and then when you're done, you can finish that. So that's not a problem.
You have it by noon on Friday.
Noon on Friday, so I put 12, but not the right 12?
You put 11:59 a.m.
AM. You prefer midnight?
Yes.
I can go change that. Okay, what else?
You
Yes.
said it's comprehensive. Is it comprehensive like the other ones have been comprehensive? Like where it's maybe a fourth comprehensive, 3/4? Or is it more? Is it
No, it's going to be much more comprehensive.
Okay.
So there will be a little bit more emphasis on the multiplication division unit because I don't know what you know about that. So probably most of the question, let's say this, out of all the units, that one will be the highest percentage of number of questions. But it won't be much higher than the others.
Okay.
In other words, we'll see a lot of number theory, quite a few sets of numbers, a bunch of... what can we do to prepare? Look at your old tests. Make sure that you have written down or found answers to anything that you missed. And even review the ones you got right because maybe it's been a while since you got them right. So that could be helpful as well. What else could we do to get ready? Yeah, Christy.
I was gonna say look at our personal resources, like that's like
Personal resources. If you have done the kind of job that we've expected, all of it is all compressed into one spot. All of the vocabulary is there to review, the questions that wonderful idea. Yes. What else can we do?
I have a quick question. How do you tell what ones you missed on like the scanning?
The only way you know that is you can look at your score and see how many, but you can't tell which ones because you don't have a key available. So drop by my office or
Christy first.
yeah.
With the test repentance policy that you have,
Uh-huh.
does that go into the end of the semester or?
It would be nice if I had a way of doing it with each test, but everybody knows what she's talking about? After the final is graded, I will throw it into the raw score in, and I'll have 4 raw scores, test 1, 2, 3, and 4, or number theory, sets and numbers, addition, subtraction, multiplication, division. Then what I'll do is I will go into iLearn and I'll download those 4 test scores into a spreadsheet. I will then, I've got a little formula that I've worked out, and it goes through and it looks at test 2, and if it meets the criteria, it goes back and looks, is test 1 repentable? Is that a, no. In other words, can it be adjusted up, because the requirement says if it's already a 90, then I can't do anything with it. So it asks all these questions. If it can be adjusted and number 2 qualifies, it adjusts it up. And then it goes and does number 3. And if it qualifies, it comes and adjusts up 1 and 2, if that's, and then does 4. And then I get those all changed, and I upload those new scores into iLearn.
No, with the criteria, it is that there's an improvement and then it doesn't exceed minimum, correct? Is that the only requirement?
No, that's not the only requirement. You go back and read it. There would have to be improvement, because if you're gonna, because you have to meet a certain threshold in order for it to kick in. I have to know you've improved enough that, yeah. If you have specific questions about how it works, you can ask me about it. And you can even say, here are my 3 grades. Tell me how that's gonna come out. I can even talk to you about that. Okay, which means when you take the final, if your first 3 exams are low enough that, if they're not up to 90, they could all get adjusted as a result of your final exam. And some exams could possibly get adjusted 3 times. Like if you had a 60 on number 1 and you got a 85 on number 2, it would adjust number 1. Then if you did say you got a 90 on number 2, it would go back and adjust 1 and 2 actually at that point. And then the final might cause all 3 of them to come up, and that would mean number 1 would get adjusted 3 times. Depending on how you did, the amount of adjustment would vary, but that will take place shortly after the final exam gets posted. Give me time to download them and adjust them and reload them. What else?
Are you going to fit all of your 205 classes in here, or are there other
No.
schedules for them too?
No, the other one meets at Tuesday at 10:30 to noon. And if that day works better for any of you, I would invite you to come that day. Your personal resource would still be due at 2 o'clock on Monday, but if Tuesday at 10:30 works better for you, just show up. I'll have the same exam and that, if that works better for anybody. So no, they won't all be in here. Quiz questions from today's quiz. Yes? No? Okay? We're all right?
Can you do the last question? It's like 4 times 10.
Do you want to read it?
4 times n base 7.
Clock 7.
Clock 7. N.
And?
plus clock 7 to 5 equals 1.
Okay. This is a repeat of what we explained to you in the homework, but this is somewhat like this problem right here. 2x plus 3 equals 15. Solve for x. Okay? So I'm going to do this one a little bit different because then you'll be able to see how it works here. Tell me which is easier to solve. This equation or this equation?
The 2x plus 3 equals 15.
This one's easier than this one?
It's already solved.
This is solved?
Yeah, that one's already solved.
See, the negative fraction really freaks everybody out. But what's the answer here? X equals negative 3/4. Why is it so easy? Two identities. Timesing by 1 does what to x? Nothing. Adding 0 to x does what? Nothing. So that's the same as having x equals negative 3/4, right? So if I could turn this into identities, I would be done like this. Well, how do I get identities? What produces identities? Inverses. So, what's the inverse of 3? The additive inverse, since I'm adding. Negative 3. So I'm going to add negative 3 to both sides. Add a negative 3 to both sides. When I do, I get 2x plus 0 equals 12. Okay? How do I turn this into an identity? Okay? In other words, I use an inverse. What's the inverse of 2? Now, what kind of inverse? It's the multiplicative inverse of 2, right? And how do we know that negative 3 is the additive inverse of 3? Because 3 plus negative 3 equals the identity. And that's what I want, because that makes solving real easy. Okay, so what is the multiplicative inverse of 2? 1/2. Because 1/2 times 2 makes 1, the identity. So I'm going to multiply both sides by the multiplicative inverse. That gives me what? 1x, half times 0 is 0, equals half times 12 is 6. So now it's just like this one, it's what? X equals 6. Okay? That's probably a little bit different than your algebra teacher taught you. Probably said, oh, when you're adding, you subtract 3 from both sides, right? But subtracting 3 from both sides is the same as adding a negative 3, right? And then he's probably said divide by 2 on both sides, right? Or she's, whoever your teacher was. But we did what? Multiplied by 1/2, which is the same as dividing by 2, right? We define it. Okay, so now that we've got this, keep the same idea going. What is the additive inverse of 5 in clock 7?
2.
And how do we know? Well, how do you find an inverse? It's going to be the number which, when I add, gives me 0, the additive identity. What number is that in clock 7? 2. Right? So guess what I'm going to do? I'm going to come up here and I'm going to add 2 to both sides. That gives me 4 times n plus 0, because 5 plus 2 is 7, but the remainder is 0. Over here I get 3. Now what are we going to do? Well, we've got to turn this into an identity. The way to get an identity is with a inverse. So my question is, what is the inverse of 4? So that's 4 times what in clock 7 gives me a 1. Well, I don't have my clock 7 facts memorized, so I just have to find this. Let's see, 4 times 1 in clock 7 would be 4, because 4 times 1 is 4, and when we divide by 7, it goes in 0 times with a remainder of 4. 4 times 2 in clock 7 is, 4 times 2 is 8. Divide by 7, we get a, oh, that's nice. We got there quite quickly. Guess what the inverse of 4 is? It's 2. Because it produces the identity. Well, that's what I want here. So guess what I'm going to do? I'm going to multiply both sides by 2. And I'm going to multiply them in clock 7. So, 2 times 4 is 1. I now have 1 times n. And 2 times 0 is 0, right? I have to distribute this across this plus sign here. And 2 times 3 is 6. In clock 7, it's still 6, because 7 goes in there 0 times with a remainder of 6. So, guess what? We're done now. It's just like this problem right here and this problem right here. Once you get everything to identities, you are done. So now 1 times n does nothing. Add 0 does nothing. I have n equals 6. Are we finished?
Yes.
We should check it. Let's take our answer 6, plug it in for n, and see if it really does give us 1. 4 times 6 plus 5. 4 times 6 is 24, but in clock 7 it would go in 3 times with a remainder of 3. So my new problem is this. 3 plus 5 is 8, but 8 in clock 7 goes in once with a remainder of 1. And that's what we needed it to be equal to. We know we're correct. Does that make sense? The thing that looks a little bit strange about this is we would say subtract 5 from both sides, right? But no, you've got to use the inverse to get the identity. Use the inverse to get the identity. And once you've got the identity, you've got it solved. Does that make sense? That's really what you're doing in algebra. You're using inverses to create identities, which leaves the x all by itself with nothing happening to it. It's probably not what your algebra teacher taught you at that point, but that's really what's happening. Which goes to prove that many of you can learn to do algebra and not understand anything about why you're doing it. Okay. Any more on the quiz? That was the toughest one, I think, on the quiz. Okay. Let's talk today about estimating and mental computation. We had a section on this in our addition and subtraction. Estimating and mental math. Estimation is always mental, but mental math can be getting the exact answer. I'll start off by telling you this true story. my oldest daughter, who now has 5 children, came home as a 3rd grader, and back in those days we had a milk cow, and I was headed out to milk the cow, and she came out with me, and I'm milking the cow, and so I do what we typically do. I say, well, what did you learn in school today? Oh, we learned this real cool trick in math. I said, oh, really? Why don't you tell me about it? She says, well, give me a 1-digit number and a 2-digit number. Okay. How about 6 and 48? And she goes, 288. And I go, what's that? She says, I just multiplied them. She has no paper, no pencil out there. She's a 3rd grader. I said, that's pretty cool. Give me another one, she said. So I gave her another one, and just that quickly. So I said, so tell me how you're doing this. I suspected what was going on. She said, oh, it's easy, Dad. Mr. Tiger just said, what was the one I just gave you? 6 times 48. Mr. Tiger said, just break the 48 up into 40 and 8. Because 48 is really 40 plus 8. And you just go 6 times 40, and you can do that in your head, she said. 6 times 40 is the same as 6 times 4 with a 0 on the end, so that's 240. And then she said you just do the 6 times 8, which is 48, and you add the 48 to the 240, and that's 288. So what was she doing? She was saying that's the same as, and that's the same as, right? Which is the same as,
Isn't it distributed?
it is. She was doing the distributive property all in her head. Now, is my daughter brilliant? No, she was average. I said, was everybody doing this? She said, yeah, everybody was doing it. Now, I don't know, I wasn't there to see if every single kid was successful, but I'm guessing they were. This was 3rd grade, and the teacher had the entire class successfully multiplying mentally a 1-digit number by a 2-digit number. Well, I said, let me show you a little bit different twist on it. I said, 48 is not only 40 plus 8, it's 50 minus 2. And 6 times 50 is easy to do in your head too. It's just 6 times 5 with a 0 on the end, so that's 300. And then, if you do 6 times the 2, that's 12, and you just take away 12 from 300 in your head, and you still get 288. She's going, that's cool, it works with subtraction too. She was all excited to go back and tell Mr. Tiger about it. I said, sometimes it's easier to do the subtracting than it is to do the adding. She says, well, what do you mean? And I said, well, you can even do it for bigger numbers. Let's say you go to the store and you're buying 4 items and they each cost $3.99. You could take 4 times the 3, get $12, and 4 times the 90 cents. And get $3.60. You could do the 4 times the 9 and get 36, and then add the 36 and the 360 and the 12. But I said $3 is just 1 cent less than $4. So you go 4 times $4, and that's easy, $16. And then there was 1 cent that occurred 4 times, and so you just take 4 cents away from your $4, and you have $3.60. $0.96, and you can do it all in your head. She thought that was pretty cool. And it's not only pretty cool, it's something that we ought to be able to do, not as teachers of mathematics, which you are all going to be, but as citizens in a world that is constantly doing this kind of thing. But it all is based on the distributive property, right? So, distributive property becomes important when we are doing mental computations. And here was a single digit times a 3-digit with 2 decimals. And you can do it in your head with just a little bit of thinking. Anybody have questions on that? Most of you have been doing that 6 times. You've been doing that. And if you haven't, you need to. It's very doable, as 3rd graders will prove to you. Okay, I've got one other thing I want to share with you, but I need everybody to look that direction while I put a problem on the board. And as soon as I tell you, as soon as I say go, I'd like you to turn, and without using a calculator, and without using paper and pencil, I would like you to compute the answer and then yell it out as soon as you get to the answer. Okay, nobody look until I say go. Go. Yell it out. Who said it? What'd you get? How'd you get it?
I added the 36 and 64 and then multiplied it times 17.
Why'd you do that?
Because they were both multiplied times 17, so it was like reverse distributing, I guess.
Reverse distributed. I see 2 terms. Each of the terms has a common factor, 17. So you factor that out. What was left over here? 36 plus 64. 36 plus 64 is 100. 100 times 17 is 1700. 1700. What appears to be an ominous problem, a very difficult one to do. Can you imagine timesing 36 times 17 in your head? Keeping that product there while you multiply 64 times 17 in your head, and then adding the 2 results, all mentally? Well, there are some people that can do it, but most normal people can't. I can't. I consider myself normal, but some people would argue with that. So, knowing the distributive property forwards is good, but knowing it backwards is also helpful if the problem lends itself to that. What other kinds of things can we do to multiply or divide mentally? How about this one? Mental problem. You're going, what? Mental?
Well,
24 times 35? Ah! You're just, you up?
when you pull out a 10.
A 10? What do you mean, pull out a 10?
Well, 10 can go into both of them. Thank you. It's finding the common factor and pulling it out.
Finding a common factor and pulling it out?
The answer 840.
Is the answer 840?
Yeah.
The answer is 840, yeah. How'd you do it?
I did 20 times 30, and then 4 times 5, and then 5 times 20, and 4 times 30.
Whoa! She may be abnormal. No. She did the distributive property. Let's look at it. You did 20 times 30 and got
600.
600. Then you
Then I did the 4 times 30,
and got,
1,120,
and then
which is...
what's she doing? What your algebra teacher called FOIL, which is the distributive property. But now it's with two binomials, or two two-digit numbers. That's doable, but it's challenging. You didn't pick up a piece of paper, did you?
No.
I didn't see you pick it up. Okay,
No.
it's possible. Could I suggest for these two numbers an easier approach? Let's go back to Unit 1. Unit 1, number theory. In prime factorizations, or just factorizations, I notice that this is really 5 times 7. And this right here is really 2 times 12. It's also some other things, but notice 2 times 12 times 5 times 7. We know that multiplication is commutative and associative. So I can add it in any order and group it however I want. So which one should I group together? 5 times 2 is 10. 7 times 12 is 7 dozen. You guys all have that learned, I hope. It's what? 84. 84 times 10 is doable in my head. I like that method. Chris, if you can do this, go for it. I like this method better. You do too, huh?
Yes.
Okay? But it will work if you can keep those 4 products in your head and then add them together. You can do it. But notice, break up the two numbers into some factors that when you combine them makes it an easier problem. Does that make sense? So that would be that strategy. Break up the two factors into other factors which I can combine in more friendly ways. Here's another example of that. You could do something like this. 7 times 25 times 12. Just chomp on that one. See what you can do. See what you can come up with. Somebody got an answer? Okay, Devin, good. How did you do it?
So 25 breaks down into 5 and 5.
Okay.
5 times 12 is 60.
5 times 12 is 60.
60 times
So now you've used this up and that up.
60 times 5 is 300, and then 300 times 7.
Okay, anybody else see another way to approach it? That one was very doable. Anybody else see a different way to? How about this? 12 is the same as 4 times 3. 4 times 25 is 100, which leaves just the 3 times the 7, which is 21, and 21 times 100 is 2100. There's lots of ways of doing it, but this isn't real friendly. I don't know what 7 times 25 you could get. What is it, 175? Right? Then I got to take 175 times 12 and even though I washed a lot of eggs when I was a little kid growing up, I don't have 175 dozen memorized. And so I'm kind of stuck. But if I break it down in ways that are more friendly, ways that I can see how to do that, there's no need to call on a calculator. There's no need to even do any work by hand. Just break things up, recombine, called decomposition composition. You break something down and then put it back together, but in ways that are more friendly. Okay? What other kinds of things can we do to make mental computation easier? What if we did something like this? Let's see if I can. We could always do the short division that we talked about back in Unit 1. Again later in... but, anybody see a way to approach this? That as I look at this, my estimation skills say, if this number were just this, 7 would go into it real nicely, right? And then I say, wait a minute, this is only,
7 more.
this is 7 more than this.
Yeah.
So 7 goes into 350 how many times?
50 times.
50 times. So it will go into 343 49 times. Does everybody follow that? And what we could do is this. We could rewrite this as 350 divided by 7. Subtract 7 divided by 7. And really, in a way, what we have is the distributive property, but with division here and subtraction. Why is it working? Because dividing by 7 is the same as multiplying by a 7th, right? So if I had rewrite this as 350 minus 7 divided by 7, and then I can break that up into 350 divided by 7, subtract 7 divided by 7. Does that make sense? So it's the distributive property, but using division. You can, and everything we've shown you so far is to get exact answers, but do it mentally. This problem right here, getting the answer of 349 is not the, I mean, you can go, 7 goes into 34, let's see, that'd be 28, that'd be 4, and you can carry the, let's see, the remainder would be 6, 63, and you, I mean, you can do that. But it's a little easier to say, oh, that's really close to 350. Why? It's only 1 7 away. Therefore, if it's 50 here, then it would just be 1 less time 349. Okay. Let's talk estimation now. Estimation is where we want an answer that is reasonably close, but we don't want to pick up a piece of paper and calculate it, or we don't want to pick up a calculator, or we don't want to pick up, or we just want to do it mentally. So, we're not after an exact answer, we're after a close answer. So if we do 2, 3, 7, 8, 5, times 4, 6, 5, 1, how would I get an answer that's kind of close?
Do the 23,000 times 4,000.
23,000 times 4,000?
Well, no, because you can round them up because they're about 500, so.
If we're going to round it to the nearest thousand, we probably go to 24,000,
Yeah,
right? Because this is
24,000,
closer to that.
Yeah.
And round this to
5,000.
5,000. So we'd make this problem into 24,000 times 5,000. Now, is that doable in your head?
Yes.
It is. Because we've got a one-digit number times a two-digit number. And even third graders can do that, right? So 5 times 2 is 10. So 5 times 20 would be 100, right? And 5 times 4 is 20, so we have 120. And then what?
Add the zeros behind
How many zeros?
it. Just
3?
6.
6?
It has to be 6 zeros.
6 zeros. Right? Now, is this estimate an overestimate or an underestimate?
Over.
Because we rounded both of them up, the answer will be higher than the correct answer, right? If we round them both down, the answer is an underestimate, and if we round one up and one down, then we're hoping that it's going to get really close to the answer, but it may or may be over, may be under, and sometimes it's hard to tell.
So Brother Packer, to get a slightly closer answer for this problem, could you do the 24,000 times 4,500? Would that give you closer?
Did everybody hear that? If I did 24,000 times 4,500, 4,500 is closer to this number than 5,000 is.
Yeah,
I would get closer. What's the problem?
it's harder to do.
Yes, now I've got two two-digit numbers, and unless you're Chris, you could do it maybe, but here's the question you have to ask. If I have to pick up a piece of paper and pencil to do it, it's no longer an estimation. It's getting an answer that, but we want something that is mental. Estimation should be mental. Because if I'm going to pick up a calculator and do 24,000 times 4,500, I might as well do the original problem. If I'm going to compute by hand, it would be a little easier to do it by hand than to do the whole thing, but okay. And we've already talked about the decimals, right? I want an estimate here.
53 times
53 times 3? What's 53 times 3?
156. No.
159? Our answer should be pretty close to 159. Since we rounded both up, we'll probably be over again. But we could do this. Take 52 times 2. What's 52 times 2? 104. My answer is going to be somewhere between those two, because I've rounded down and got the estimate, rounded up and got the estimate. We think it's going to be closer to which one of these? the 159, because this number is closer to 3 than it is to 2, and this number is closer to 53 than it is to 52. But it will be somewhere in between those two, my low estimate and my high estimate. Okay? And again, if it's easy enough to do that, I think this would be another approach. Does everybody know what decimal a fourth is close to?
And everything to
0.25, right?
oh,
So I see a 2.5, but my decimal is not 0.25, it's 2.5, but I could still say this is really close. If I move my decimal over here, it'd be a fourth. If I found out what a fourth of 52 was, what's a fourth of 52? Since it's divisible by 4, fourth of 52 is 13. But now, since it wasn't 0.25, it was 2.5, I put on another, it's going to be, I'm saying it's going to be even closer to this one than either one of those. Somebody do the problem and see. So I handled this as though it was a quarter, but one place off. It's 135, which is closer to this than either one of those. And it's still doable in your head. A fourth of 52 with a decimal moved once because I had to... Anyway, there's lots of different ways of doing it. For your homework, you're going to get a chance to practice. We'll demonstrate, again, give you more examples like I did today, and then give you a chance to practice.